My dear students, in this video I am going to solve the system of linear equations by Gaussian elimination method. In our previous videos also we have solved the system of linear equations in various methods. First method, we have solved the system of linear equations by matrix inversion method. The given equation can be expressed as a matrix equation, and that equation, matrix equation, the matrix A, inverse of the matrix A is determined. By the matrix inversion method, we have solved the system. The second method, Cramer's rule method. We have solved the system of equations by Cramer's rule. Delta, determine coefficients of equations as formed as delta, and then x is equal to delta x by delta, and y is delta y by delta, and z is delta x by delta. Like that, we have determined the values of x, y, and z by the method of Cramer's rule. Now, our third method is solving system of linear equations by Gaussian elimination method. Gaussian elimination method is we have to rewrite the equation into a matrix form. For that, we consider this equation solve 2x minus 2y plus 3z equal to 2. 2x plus 2y minus 3z plus 3z. 2x minus 3y. 2x minus 2y plus 3z equal to 2. And second equation, x plus 2y minus z equal to 3. X plus 2y minus z equal to 3. And 3x minus y plus 2z equal to 1. See, these are the three system of linear equations given in the variables x, y, and z. We have to solve for this equation by Gaussian elimination method. In this method also, we have to find out the matrices with the coefficients of the variables x, y, and z. I explain this method first. We rewrite this matrix, this equation, system of equation to matrix form by considering the coefficients of x, y, z as the matrix. That is 2 minus 2, 3. Next equation 1, 2 minus 1, 2 minus z. And the coefficient of x is 3. Coefficient of y is minus 1. And z is 2. So you consider these coefficients of x, y, z by a matrix, and also you consider the constants as a fourth column of the matrix. This is a 3 by 3 matrix by considering the coefficients. And finally, you construct fourth column by considering the constants on the right hand side. See, 2, first equation constants 2, second equation constants 3, third equation is equal to 1. Like that, you consider this matrix, 3 rows and 4 columns matrix. So, this column represents the constant column. That's why I separated by a line. That's all. It's not a separate matrix. Remember, it is a matrix of the form 3 rows and 4 columns. This matrix is called augmented matrix. Augmented matrix is nothing but considering the coefficients as 3 by 3 matrix, and finally you construct a constant by a fourth column in the matrix. Additionally, you add the constants on the fourth column, and this matrix is called augmented matrix. Okay. Now, Gaussian elimination method means we have to eliminate the coefficients of x, y to 0. We have to eliminate these coefficients by operating the rows operation. In this case, you rewrite a second equation to first equation, r1 to r2 and r2 to r1, r1 to r2, r2 to r1, because always our first row, first element should be 1. Always our first row, first element should be 1. For that, I take that second row into first row and first row into a second row. Rearranging like that, I will get 1, 2, minus 1, 3. Second row becomes first row and first row becomes second row. That is 2, minus 2, 3, 2. Third row as it is, right? 3, minus 1, 2, 1. Okay. Now, you subtract, you make this second row first element to 0 and third row first element to 0. For that, okay, second row, you consider second row R2 by R2 minus 2 times of R1. If you multiply R1 by 2, you get 2. 2 minus 2, 0 you get. Second row first element becomes 0. Operating the row operation, keeping R2 as it is and subtract from R2, you multiply R1 by 2. R2 minus 2R1. That is, first row you need not alter. Second row, R2 is R2 minus of 2 times of R1. 2. 2 times of R1 is 2. 2 minus 2, 0. And this is minus 2. 2 times of R1 is 4. 2 into 2, 4. Minus 2, minus 4, minus 6. And 2. R2 is 3. And 2 times of R1 is 2. 2 into 1 is 2. Minus 2 minus of minus plus 2. 3 plus 2, 5. Because 3 minus or minus 2 is plus 2. 3 plus 2, 5. And this is R2 is 2. 2 times of R1. 2 3s are 6. 2 minus 6. 2 minus 6 is minus 4. 2 times 2 3s are 6. 2 minus 6 is minus 4. Okay. Similarly, R3. You rewrite R3 is 3 times of R1. R3 minus 3 times of R1. Because 3 times of R1 is 3. 3 minus 3 is 0. R3 is minus 1. 3 times of R1 is 3 2s are 6. Minus 1 minus 6. Minus 1 minus 6 is minus 7. And R3 is 2. 3 times of R1 is minus 3. Minus of minus plus 3. 2 plus 3. 3 into minus 1 is minus 3. Minus of minus plus 3. 2 plus 3 is 5. And R3. 1 minus 3 times of R1 is 3 3s are 9. 1 minus 9 is minus 8. After giving these two row operations, you will get the matrix of the form 1, 2, minus 1, 3, 0, minus 6, 5, minus 4, 0, minus 7, 5, minus 8. See, like that you have to eliminate the coefficients of x in both the rows, second and third row. And I am going to eliminate y coefficient next in the third row. I am going to eliminate y coefficient in the third row. For that, I am going to operate R3. R3 is 6 times of R3. I am going to rewrite R3. 6 times of R3 minus 7 times of R2. 6 times of R3 is 6 7s are 42 minus 42. 7 times of R2 is 7 6 are 42. Minus of minus plus. Minus 42 plus 42. This term becomes 0. For that I am doing this operation. For that, first 1, 2, minus 1, 3 is not altered. Second row is also not altered. That is 0, minus 6, 5, minus 4. And third row becomes 0, 6 into 0, minus 7 is 0. This 0, both terms are 0, therefore this is 0. 7, 6 into R3 0, 7 into R3 0, 0 minus 0, 0. 6 into R3, 7 6 are 42, minus 42. 7 into R2 is 7 6 are minus 42, minus or minus plus 42. Minus 42, minus or minus plus 42 becomes 0. And 6 times of R3, 6 5s are 30. 7 5s are 35. 30 minus 35, minus 5. 30 minus 35 is minus 5. 7 5s are 35. So 30 minus 35 is minus 5. Similarly, 6 8s are 48. Minus 48. 7 4s are 28. Minus 7 4s are minus 28. That is minus 48. Minus of minus plus 28. You will get minus 20. So this has become minus 20. So that's all about the operations. So after finding this operation, we rewrite this equation. This is x term 0, y term 0, this is only z term, therefore minus 5 is that. Minus 5 times of z. The x0, y0 minus 5 times of z is equal to minus 20, because this is the third column constant. Third equation constant minus 20. So minus 5 z equal to minus 20, z equal to 4. This is the Gaussian elimination method. And then from this second equation, second row, minus 6y plus 5 is that equal to minus 4. Here minus 6y plus 5 into z is 4. 5 4s are 20. This is minus 6y equal to minus 4. Minus plus 5 4s are 20 plus 20. If you bring it to the right hand side, it is minus 20. It is minus 24. Minus 24. Minus 6y equal to minus 24. Y equal to 4. Y equal to 4. So z equal to 4, y equal to 4. Next, x, using these two equations, x plus 2y minus z equal to 3. From first equation, from first row, x plus 2y minus z equal to 3. X you don't know, plus 2 into 4, y is 4, z is 4, equal to 3. X plus 2 4s are 8, minus 4 equal to 3. X equal to 8 plus 4 is 4. 8 minus 4 is 4. X plus 4 equal to 3. If we bring that 4 that side, minus 4 plus 3, that is equal to minus 1. X equal to minus 1. Therefore the values are x equal to minus 1, y equal to 4, z equal to 4. The solutions are x equal to minus 1, y equal to 4, z equal to 4. That's all about the solution for the system of equations by Gaussian elimination method. Okay. So after eliminating the third row, the x and y coefficient, you can straight away find out the z. Similarly, from this equation of z, by second row, we will get the value of y. From x and y, we can determine the value of x. That's all about the problem. Okay. So second problem, solving this system of equations by Gaussian elimination method. For this also, you have to construct an augmented matrix. Augmented matrix is considering the coefficients 2, 4, 6 and the constant is 22. And 3, 8, 5, 27. And minus 1, 1, 2, 2. Okay. See, this is augmented matrix considering by fourth column the constants. Now, I already told you first row, first element should be 1. Therefore, you rewrite R1 to R3 and R3 to R1. Exchange R1 to R3 and R3 to R1. Therefore, you will get minus 1, 1, 2, 2. Second row, nothing, change, 27. And third row is 2, 4, 6, 22. Okay. This is our first operation. Similarly, second R2 is R2 plus 3R1. Because here minus you have, therefore you multiply R1 by 3 and you add, you will get 0. R2 plus 3 times R1 is minus 3. 3 minus 3 is 0. Similarly, R3 plus 2 times of R1. Therefore, I get minus 1, 1, 2, 2, R2. R2 plus 3 times 3 minus 3, 0. R2, 8. 3 times R1, 3. 8 plus 3, 11. 5, R2. And 3 times of R1 is 3 2s are 6. 5 plus 6, again 11. 27. 3 times 6. 27 plus 6. 2 3s are 6. 27 plus 6 is 33. And R3. 2 times of R1, minus 2 plus 2, 0. 4 into 2, 4 plus 2, 6. 6, 2 times of 2, 2 2 are 4, 6 plus 4, 10, and 22 plus 2 times 2 2 are 4, 22 plus 4, 26. Now, I divide R2 by 11 because R2 elements are constant. By 11, I divide R2 by the same factor 11 because all the R2 elements are divided by 11. I get minus 1, 1, 2, 2. This is 0, 1, 1, 3. 11, 1 divided by 11, 1, 1, 3. This is 0, 6, 10, 0, 6, 10, 26. That was right actually. Okay, here R3 is R3 minus 6R2. If you multiply R2 by 6, 6 minus 6 is 0. Therefore, minus 1, 1, 2, 2. Or second row 0, 1, 1, 3. R2 0 minus 0, 0. R 6 minus 6, R3 6 times of 1 is 6 minus 6 0, 10 minus 6, 10 minus 6 is 4, and 26 by 3 times 6 times of 3, 6 2s are 3s are 18, 26 minus 8, 8. That's all about that augmented matrix. Okay. Now, as usual, equating 4z equal to 8 implies 8 z equal to 2. Similarly, y plus z equal to 3. Y you don't know, z is 2 equal to 3. 2 minus 3 minus 2, y equal to 3 minus 2. That is y equal to 1. Okay? Y equal to 1. Next, first row, minus x plus y plus 2 is equal to 2. Minus x plus y plus 2 is equal to 2. Minus x plus y is 1 plus 2 into 2 equal to 2. That is minus x plus 4 plus 1, 5 equal to 2. Minus x equal to 2 minus 5. That is equal to minus 3. Minus x equal to minus 3. So x equal to 3. Therefore, the values are x equal to 3, x equal to 3, y equal to 1, z equal to 2. You substitute these values in the equation, you will get the solution. X equal to 1, 3, 2 3s are 6, plus 4, 10, 10 plus 12, 22. After giving these values in the first or any equation, the equation gets satisfied. That's all about the solution for this equation, and that's all about the Gaussian elimination method. You follow this method. This is very easy method to solve the equation. Thereby I conclude my video. We will continue the remaining topic in the next video. Thank you.